Solving trig equations, because all these different trig identities and rules that we've seen are certainly going to help us. Our compound angle formula, sine, cos, cos, sine. If it's the sine, it's the sine. Cos, cos, sine, sine. If it's not the sine, it's not the sine. And not forgetting tan plus tan on 1 minus tan tan. That's where we started. That then created our double angles. So sine 2 theta, 2 sine theta, cos theta. Cos 2 theta, which of course we could do in 3 different ways. Cos squared minus sine squared. 2 cos squared minus 1, which allowed us to make cos squared the subject, half of 1 plus cos 2 theta, or 1 minus 2 sine squared, which allowed us to make sine squared the subject, half 1 minus cos 2 theta, and our tan, 2 tan theta on 1 minus tan squared theta. That then created, the tan one certainly, the t results, which you could think of as half angle results. So if t was tan half of theta, then we know tan theta is 2t on 1 minus t squared. That's our double angle result for tan. But then we worked out that sine theta would be 2t on 1 plus t squared, and cos theta would be 1 minus t squared on 1 plus t squared. Then we have the lovely products to sums that we all love. So 2 sine cos became sine plus sine. And if you forget, well, this is the one that is on the reference sheet, isn't it? Yeah. But if you don't look at the reference sheet, think about where it came from. If you end up with sine cos, it must have come from the compound angle of sine. And so we end up with the sine, one's the sum, one's the difference. Cos cos must have come from the cosine one, but we're left with the cos cos, so we're adding the two together because the sine sines are cancelling out. Whereas if we're left with the sine sines, then again it came from the cos, but we must be subtracting them because we're left with the sine sine part. Of course, another way you could write that, and you might think, well, why would you? Because now if you look at all 3, then the first one's always the sum and the last one's always the difference. So if you remember, that last one is minus cos and then plus cos. You know, it always starts with sum, always goes with difference. Going back the other way, 2 sine half sum cos half diff, 2 cos half sum cos half diff, and minus, because this one's a little bit different, minus 2 sine half sum sine half diff. Okay, asterisk on that one because that's not on the reference sheet, those ones. Let's go and solve some trig equations. The idea basically is we want all the angles to be the same thing. So if we've got a mixture of double angles and single angles, we want to rewrite it. Then match the range of our answers to whatever the angle is. So if they tell us theta goes between 0 and 360, but the angle we're working with is 2 theta, then we know we've got to find angles between 0 and 720. Make the trig functions the same. If in doubt, take everything back to sines and cos. That's usually a good idea. And of course, check your answers. Remember, if you change the equation, you might create new solutions that are solutions to the new equation, but might not be solutions to the original equation that you were asked. Okay, let's start with the very basics. So cos 2 theta is a half. We're going between 0 and 360. For this one, therefore, I'm going to look for answers between 0 and 720 because I've got 2 theta. Yeah, okay, first and fourth quadrant, cos is positive. Just draw myself up a little diagram there. Okay. Now the ratio is a half. The acute angle is 60 degrees. So 2 theta will be that acute angle, or in the fourth quadrant, 360 minus it. I get 4 possibilities for 2 theta because we're going around twice. Divide by 2, and we have our answers. So that were probably the first ones we start off looking at. Of course, another way we could do that now, cos 2 theta is a half. I could rewrite cos 2 theta as 2 cos squared minus 1 if I wanted to. No, I mean, there's another 2 choices I could have, but let's say I did it this way. And then I'd go, well, cos squared's 3/4, so cos is plus or minus root 3 on 2. So actually, I'm in all 4 quadrants, and the acute angle would be 30 degrees, because cos of 30 is root 3 on 2. There's my 4 possibilities there. Same answers, of course. Then we jumped into this idea where we used our trig identities and said, well, hang on, I've got a sec and I've got a tan. Let's make them all tan. So sec squared is 1 plus tan squared. I create a quadratic equation. Nicely, this one factorizes. So tan is either minus 1/4 or positive 1. If it's minus 1/4, second or the fourth quadrant. Solving that one, acute angle approximately 14 degrees 2. And so I get 165.58, 345.58. Tan x is a little bit easier because it's an exact value. It's still one of our exact values. It is, of course, 45 degrees. Put it all together in a final solution. I like to put them in order. I just think it looks nicer. So 45, 165.58, 225, 345.58. Cos 2 theta. Got lots of choices here. What to do? Will I make them all coses or sines? Or maybe I'll just change the cos 2 theta. Yeah. Change the cos 2 theta to cos squared minus sine squared. I can now rewrite this to make it tan squared is 3. So tan is plus or minus root 3, a nice exact value. I'm in all 4 quadrants. Acute angle 60 degrees. We have our 4 answers. All right, let's grab one from a past HSC. Ooh, quite old. Cos 2 theta is sine theta. Well, this time I'll use the 1 minus 2 sine squared. Make them all sines. And we have our quadratic. Factorizes nicely. So sines are half or sines -1. So a half gives us the answers of, there we go, 30 and 150. Sine theta equals -1 is a boundary value. So I know that one's just 270. Write my final answer down. There's my 3 possibilities. 30, 150, 270. Okay. Oh gosh, let's go back even further in time. 2 sine squared theta is sine 2 theta. Okay, well this one I'll change the sine 2 theta. 2 sine theta cos theta, which is a quadratic. Factorize it. Sine theta is either 0 or sine theta is cos theta. 0, boundary value. But this brings up a good point. Remember, if 0 is a solution, 360 is a solution as well. Often forgotten. Sine theta equals cos theta. Tan theta equals 1. So we have, for our acute angle, 45 degrees. Putting it all together, we have 5 answers for this one. Make sure you know whether they want radians or degrees, and they will tell you that. In this case, they've said theta's between 0 and 2 pi, so radians is what we're looking for in the answer here. Product to sums. Sine must have come from the compound angle cosine, because it goes cos, sine. Okay, so we have minus cos 4 theta plus cos 2 theta. The cos 4 theta I can now change using double angle, and I've now got all the angles as 2 theta. It's quadratic, but now that I'm talking about 2 theta, I'm going between 0 and 4 pi, going around twice. So cos 2 theta is 0, or cos 2 theta is a half. Well, 2 theta, for our first possibility, we get pi on 2, 3 pi on 2, 5 pi on 2, 7 pi on 2, which divided by 2 gives me those 4 possibilities. Cos 2 theta is a half, first or fourth quadrant. Acute angle pi on 3. There's my possibilities for 2 theta. Divide. Now comes the fun, putting them in order. Come on, it's much more fun than just writing all of them down. Which one's bigger than which? Well, that's where you've got to know your fractions, isn't it? So we go pi on 6, pi on 4, 3 pi on 4, 5 pi on 6, and so on. All right, let's get a little bit more recent. 2021, this was nice. Extension 1, the numbers A, B, and C are related by the equations. A is B minus D, and C is B plus D. D is some constant. We have to show this expression. Well, they've told me A is B minus D and C is B plus D, so it kind of makes sense to substitute that in, and that's what we get. So on the top, but actually, look what I did. I used sum to products rather than bothering expanding the whole thing out. So the top became 2 sine B cos minus D, and the bottom became 2 cos B cos minus D. The cos minus D's cancel, the 2's cancel. Sine on cos is, of course, tan. So whilst they don't give us those formulas, that would have been very handy to remember in 2021. Okay. Hence or otherwise, oh yeah. So now we're going to use that to solve this equation. How does it relate? Let's have a look. I'm going to use simultaneous equations. Remember, B minus D was A, B plus D was C. So 2B is A plus C. Well, that means B is A plus C on 2. So for our one, it's going to be 11 theta on 14. No one said it was always going to be nice, neat numbers. Okay. Well, wait, watch this one. Theta is going between 0 and 2 pi. I want 11 theta on 14. So 11 theta on 14 will go between 0 and 11 pi on 7. So I'm looking for answers between 0 and 11 pi on 7. Yeah, I'm in quadrant 1 and quadrant 3. So we get pi on 3 and 4 pi on 3. And by the way, 4 pi on 3, of course, is less than 11 pi on 7. Oh. So, yeah, so we include it. But now we make it theta, and there's our 2 possible answers. All right.